So, or even let's not think about aspiring to that kind of impact. But yeah, so he wrote them down, he nailed them on a church door, but then somebody else scribbled them and copied them, and then it went into the printing press, which had conveniently been invented about 67 years earlier or something like that, right? By a guy in the same country, Gutenberg, right? And what that meant, and that here you see actually a print of the 95 Theses from the same year, right? I mean, for the time, the 16th century, that was an astonishing speed. And that resulted in one thing: the end of the Catholic Church as the only Christian church, right? Well, not entirely true. I mean, there was always the, Eastern churches, right? So, but I mean, it resulted in Reformation, right? But it's interesting to understand there was a very similar guy to Martin Luther, Jan Hus, about a century earlier. You know what happened to Jan Hus? Well, the Roman Church invited him to a meeting and then burned him on the stake. Right? So to a certain degree, the difference between Jan Hus and Martin Luther is media technology. Because with Jan Hus, they could still contain the message. With Luther, after 2 weeks, it was known in all German-speaking lands, thanks to the printing press. Right? That's new media impact. So it can be disruptive, but we also need to realize there's nothing inherently disruptive versus the existing order. It might also that the existing order becomes very adept in using the new media, right? It's not automatically something that is there for disrupting existing things. And, so I mean, one thing that I find interesting, so if you read about TV history, for example, in this country, you probably read that the BBC started the first TV broadcasts in 1936 or 37, right? You find that in a lot of US, media history books. Unfortunately, it's not true. There were some other guys who started a regular broadcasting TV service before. We might not want to talk about them, but it was Nazi Germany who started the first TV news broadcast in 1934. So a couple years before the BBC. Right? So that also alerts us to, is TV democratic? Yes, it has democratic potential. But, dictatorships might just be as well, adapt to using that, right? Okay, so there can be considerable disruptive societal effects from new media, right? And when there's sort of this new media comes, old media is completely replaced. Has been claimed so many times, never happened, right? I mean, there was honestly a time when I thought I had to buy my last record player and really invest into a record player so it will last. Vinyl is everywhere. I even hear the compact cassette is coming back. What a stupid idea. Nobody needs that shit, trust me. Right? So, right? But so it never, new media never fully replaces old media. The radio is still around. TV has not replaced the cinema. We can go on. Right? I mean, the market share might become much, much smaller. Right? But similarly, I think there might be a market in the future for handcrafted video games with no AI. Right? That might even be part of the PR material. And people might buy a game because of that. Right? So AI-less game design will not disappear. Right? To make that very concrete here. But there will be jobs. So jobs will be lost. Right? I think especially right now when I see our students at my institution who want to become game artists, I'm really concerned. All right? I mean, it's probably not completely there yet, but that's not really the question. Will there still be game artists in a game studio? Yes, but it will be less, and their job will be more like overseeing the Gen AI process. And I mean, if you think of a printing press, I mean, scribe is not a job anymore, which you can make a living, and it used to be a job for thousands of years. Right? There were long family tradition of being scribes. It was wiped out. So that's just happening. And then another interesting thing to observe, and it happens with different speeds, but very often the technology is first, and artistic use of it is later. You can see that very clearly with the invention of printing press, which came about 1440. It took 160 years basically until the first modern novel. Right? Don Quixote. Right? And so it took a long while until writers really understood, the advantages of this thing and how they could use this new printing form for a long-form novel as we understand it today. And in this regard, I also find it very interesting what Don Quixote is about. It's about the dangers of reading. Right? So the guy reads so many, knights things or stories about knight that he thinks he is a knight. He enters this universe of the book, right? The fictitious reality, and he cannot get out of it anymore. And that's the first novel, about the dangers of getting lost in a fictitious world created by writing. Right? Interesting to think about. But similarly, I think we can make the claim that advances in AI have surpassed the AI being used in games in general for quite a while. Right? I was actually the external examiner on a PhD thesis sort of a couple of weeks ago, and makes exactly the claim that this thesis has been making. And I'll give you a link to it later, I'll show you later more from it. But in a sense, there is a bit of a catching up between where AI is and where the use of AI in games is. There are more opportunities to embrace there. All right? But that's also kind of normal, as we see from my example here. All right. So why am I talking about these internal laws, right? Because I think the concern that we have this new media moment is not new. It has happened before with the introduction of the printing press, of the radio, of TV, of the cinema. And if we know that, we understand that we can learn from these prior transitions. Right, so talking about AI in games. Quick question, when was the first AI-based game? Rogue, that would be 1980, okay, not bad, okay. Eliza, that's 1966, okay, also not bad. Well, it depends how you see it. I mean, at least it's a chatbot, and for people like me in interactive narrative, we see it as sort of a first interactive narrative. Okay. Yes, okay, all right. So, we'll come back to it, right? But, I mean, let's get at it from a little bit of a different angle, right? So we should also understand that there's always hype about AI being new, right? AI isn't new, right? It's an idea that people have worked on, especially generations of computer scientists, for 70 years almost, right? I mean, with the term being coined in 1956 at a conference at Dartmouth College, right? So AI is older than I think anybody in the room here. If we think conceptually, we might trace it back even earlier to ideas that Roosevelt's science advisor Vannevar Bush had, right? In a famous article, As We May Think, published in 1945. Right? And as we see, we can even get way further back. Right? So we're seeing the results of a multi-generation effort that now becomes ripe for using it for sort of more average people in a sense, right? And here's an interesting prediction made by Konrad Zuse in 1938. In 50 years, a calculating machine will defeat the world chess champion. He was off by 9 years. Right? So, if you never heard about Konrad Zuse, he invented the first Turing-complete computer in 1941. Luckily, the Nazis didn't understand the potential. Right? So they never used it for encryption, which might have been catastrophic. Right. So, this is probably the first game you can call an AI game, what you see here. It's a game of checkers. It's created by Christopher Stracey in 1951. Okay, it ran out of memory in the computer in 1951, but he ported it to a different computer, so it was really running in 1952. That's how long ago. Right? So, and he also created something like a Mad Libs on the computer for creating love poems. He was also gay. Not the easiest position to be in, and he was actually a classmate of Alan Turing. Right? So it's also sort of a heteronormative expression or critique of heteronormative expressions of love. So that's what we need to think, 1952. Right? That's sort of a starting point. And of course, and this is why Zuse was a number of years off, right? Because it was only in 1997 and not in 1988, as Zuse had predicted, that Deep Blue beat Yuri Kasparov, right? So AI had, from the very beginning, a connection to games. Right, a connection making games or having an AI sort of counterpart to play with, but also seeing AI or seeing games as an important benchmark. Right, beating first chess in 1997 and then Go in 2015. So Go has a much wider space to explore of possibilities, and that's why it took so much longer. Okay, if we go into AI and games, and these are just some examples, and here, here are some examples also out of my direct sort of field that I work with, narrative focus. So yeah, 1966, Eliza, Victoria already mentioned it. If we talk about story generation, as we saw, the love letter generator is from 51. And there's some other, there's evidence of other systems from like 1960, 61. Right, so that also goes way back. But then, of course, milestones was Facade. Anybody here has played Facade? Okay, try to find it. Right? I think there's a version that you can play. I mean, it came out in 2005, was actually produced down the road here at Georgia Tech by Michael Matthias and Andrew Stern. And you are, well, in the apartment of a couple who's fighting. and you try to get them to understand that, you know, their marriage will break apart if we don't do anything, and you know, they should probably have a couples therapy, right? But you interact with them through free-form text. So it's natural language processing, which maps it to the behavior of the two characters. And you can actually get them to agree to a therapy, right? And that is 20 years ago. Right? Unfortunately, Michael Matthias didn't really follow up, or, you know, not directly, but I mean, when his students built Prom Week, which you see here in 2012, which is sort of a simulation of a whole class of students, and you're trying to find somebody in 1 week to go to prom with you. Right? Yeah, maybe not happening, but yes, I see. Okay, but I mean, I think many here can sympathize with the stress of this situation, so it's sort of a social simulation. Right, but there's other things, right? Procedural content generation, and somebody here already mentioned Rogue, right? To which all the roguelikes, of course, trace back to. That was in 1980. Actually, A la Cabef was a little earlier, but same year. Right? Then, of course, we have things like Diablo, a really breakthrough game in many ways. We have Dwarf Fortress in 2006 and No Man's Sky in 2016. And yes, I know when it came out, it was terrible, and it took many, many years, you know, to make it a good game. I think it sort of became one eventually, but the idea is it can procedurally generate the planets you're flying to. And its system can create 14 trillion planets, right? I mean, my esteemed colleague Kate Compton said, yeah, I can also make 14 trillion bowls of porridge, and they will not be meaningfully different, right? And that was unfortunately true when No Man's Sky came out. The planets were not meaningfully different, but that has been considerably improved, right? But it showed the potential of procedural generation. Right, another example is of course pathfinding, right? And pathfinding, I mean, maybe the first famous example is Tactics, and I think that's the wrong image that I have here, sorry for that. Made by Chris Crawford, who wrote extensively in The Art of Game Design about it. Robert Odyssey in 1984, and then we have with Diablo and the Elder Scrolls 2 Daggerfall, we have the A-star pathfinding algorithm, which is was much improved, right? Another example is finite state machines, right? Finite state machines being used to have, in a sense, more intelligence, reactive enemies, to be able to have something like, you know, a baseball coach that responds, and a whole team that responds to you, and of course real-time strategy games. Herzog 2 from 1989 might be the first example of that one. Okay, and then of course neural networks, and that took a while until that was kind of successfully implemented, but we could probably say that Creatures from 1996 is the first successful example here, right, of having virtual creatures that you can attend to. Right? So overall we can say what were the use cases in AI in games? Well, playing games, as I mentioned, was already there from the beginning of AI, procedural generation, intelligent functions within games, and then, of course, game testing. And here there are very good examples recently. For example, Moodle AI, somebody also there. Some game researchers are directly involved. This is a company that includes Julian Togelius, a big name in game AI. And of course these things can basically automate game testing, right? Do the bug hunting for you, find out what the problems are, and also provide sort of virtual co-players, right? Okay, so then what's actually new with generative AI? Since we've seen that, AI has been used for such a long time. And I think it's a number of things, right? I mean, it's concept art and 2D assets, right? I mean, this is something that I quickly produced with ChatGPT. Give me a mood board for a game that will be about Phoenician seafarers, making mostly green and brown. Bang, there I am. I have a mood board. And the other thing was, give me a background for a side scroller. There we go. Another thing, dialogue trees. Right? This is output from Claude. Specified, produce a dialogue tree between the interactor and NPC, who is a janissary in 1560 about his allegiance to the Ottoman ruler. Depending on the choices, the interactor might be taken prisoner for being disloyal, might be invited to join the janissaries, or convince the NPC to betray his cause. So such things can now easily be produced by generative AI. Also, simple 3D models and textures. Right? A cute tiger character, big eyes. Bang. Is it good enough? Of course, that is still a question, right? But we'll come to that. Right? Or we can have whole code generation and review. Here are two examples of games that I just made. I didn't write a single line of code, but they run. Right? What you see to the right was basically a task for Claude, create a text adventure with certain parameters, write the Python code for it, bang, it was there, it runs. Right? It doesn't crash. And what you see to the left is v0def, and where I said, okay, create a library game in the style of restaurant management games, where you have an incoming flow of books, an outgoing flow of books which you need to manage, and at the same time patrons ask you questions, and you need to manage all of that and make sure, and you lose when it piles up. Right? Took like 3 minutes to produce. It runs. So this is where we are now. Right? And of course, oops. Okay. Right. Background music. Right? Can probably be used in a game depending on the movie, right? But I just described that. Bang, it was there. Right? And you haven't tried Sumo, you should. It's amazing. And another thing that I tried, just out of curiosity, criticism for game ideas. Right? So, is it a good idea to create a game about the slave trade which includes a mini game of slave Tetris? Right? And if you think this is absolutely horrendous, it is, but actually that game exists. You can Google it. Right? And I mean, of course, the developers argued it really shows how horrendous the whole thing was, because literally human beings were stuffed into and packed as tightly as possible in the ship's hull. Right? So we had an argument for it. We said, no, we really want to show how horrible this is. Right? But I mean, the backslash was considerable. And the game was taken down after a short while. And I mean, so I found it interesting to see what ChatGPT would say, and basically says, okay, this is a terrible idea. Right? So, I mean, I actually initially expected to fail in terms of game idea criticism, but I tried a couple other things, and it did pretty well. Right? So if you need somebody to bounce back idea with, it doesn't do horrible. So with all of that, everything will be AI, right? No need for game developers anymore, and now I drop the mic and run out. Right? Well, okay. I think it's absolutely crucial to understand the limitations of generative AI tools, right? And also to understand this. These current generative AI tools, they are not creative by itself. What you see is the remediated, the resampled creativity of millions of people before you, whose creativity has been harvested. You know, starting from the cave paintings to, the Mona Lisa, to Dürer's hair, to Van Gogh, to whatever. It's all in there, right? It's sort of amplified, repurposed, remixed, sampled, right? We all remember, when sampling was a big thing, there were copyright lawsuits between different musicians. Oh, you sampled 20 seconds of my music, is this allowed? It's a bit like that. It's not creative by itself. It's a fantastic pattern matching algorithm. That's what it does. It looks at what you wrote in the prompt and then tries to pattern match something to it. I mean, the beginning of all these LLMs is predicting the next word. That's underneath it. You write a word and it tries to predict what would be the next word so it makes sense by looking into billions of texts before. So I think that's important to realize that generative AI might look so strong and good because it sits on all of that. On what many, many generations have done before us. Right? But it also should be clear that generative AI tools repeat and amplify the limitations and the biases of data sets. Right? So I actually spoke at a library event yesterday at the University of Miami. And so, I made some prompts regarding librarians, right? So librarians as magicians of knowledge. Why is that a man? Right? And when I put a similar thing not only to ChatGPT but also to Stable Diffusion, of course also a man. Right? Only when I put in modern day became it a woman. Right? And friendly and competent model, okay, when I get a woman here, with, of course she's multitasking, so I'm fine actually with the, several arms. Right? I mean, that brings across the message that I wanted to get across here. Right? But it was also interesting, we looked at a number of pictures, and my host there, his partner is blonde, and she looked at all of that and said, yeah, no blonde librarian. We blondes are too stupid. Right? So, I mean, that's also a part of this whole bias thing. Right? And, I never got to that without explicitly saying non-white. Right? I had to explicitly put that in there. And then, of course, it didn't result in an Asian person or in a Latino person. Right? So is this algorithmic bias? I would actually say no, it's not algorithmic bias. It's data set bias. I think algorithmic bias is a bit overrated. The algorithm just uses whatever's in the data set. Right? And we might remember these horrific things like 5-6 years ago when African American women were recognized as monkeys. Right? By AI algorithms. And why was that? Because there were just no African American women in the freaking data set. Right? So, being aware of that and improving the data set is something we still absolutely have to do. Right? And we can see that everywhere. So, you know, again, I work a lot of interactive narrative, right? Every couple number of years comes with like, oh, AI has identified the 8 universal narrative structures. And I'm like, yeah, because we use Project Gutenberg for the data as the data source, which includes basically no African oral storytelling, no Aztec storytelling, no Aboriginal storytelling, you know, hardly anything from China. Yeah. Right? There is no universal story structure. There is a myth created by Joseph Campbell, and it's just not true. Right? And actually, in the field where he comes from, myth and folklore studies, nobody's using that anymore. Unfortunately, it's still considered the gold standards in many game design studios. Right? But again, not algorithmic bias when we see such things like with 8 universal plot types, dataset bias. Right? And that's still something to work on, be aware of. Right, and of course, the copyright question is unsolved. There are a number of lawsuits still going on between writers, between musicians, and other creatives and the big AI companies. Right? And recently came out that a company called Meta, who makes no money, I guess, probably they don't pay taxes or so, you know, they mined scientific papers from a scientific pirate site called Sci-Hub, right? With no permission. And, you know, some you know, academics were fine with that, and of course we can discuss, is it fine that journals charge, and I mean, that's a different kind of question. But outright stealing is another thing. Right? There was an article in Wired, and when they produced a nice little prompt, they could show, is my work in this pirated collection? And some colleagues were like, yes, great, I will be part of this data set, right? Yeah. So something needs to be done about this issue. One suggestion is to create sort of trade unions. So the idea of data unions has been proposed. Right? And of course, that would also apply to game design. Right? So, and of course, I would say, if you're a game designer, consider having a clause in your contract if you do not want your work to be harvested for AI. Actually, the last actor strike, remember, was not so long ago, right? Was all about that. Right? And if you're in the Actors Guild, you now have clauses about that in your contract. So we cannot simply, like, you know, make a 5-minute shoot of you and then use you forever. Because technically that's possible. Right? And also that means the job of a stand-in is gone. There's no need for the stand-in. Right? We just put Ryan Gosling from our AI archive in there when he walks away, and they don't need to see his face. Right? That's where we are. Right. And here's another thing. Generative AI output is mostly not production ready at this moment. One issue with, I mean, that's of course good news for game designers. It's also bad news for game designers, because do every, you know, AAA company boss understand that? Or are they just firing people already, even though the technology isn't completely there yet? I know the story of a Swedish game studio that fired 40% of its workforce because of generative AI. Did it turn out well for them? Other question. Right? So, but how can I say this? Well, because I did some research on it. Right? So I'm not just claiming that. Right? This is something that Victoria was there at the conference, that we published in December. So together with Miriam Palasari-Elatari and Jonathan Barbara, we looked at specifically interactive narratives, so narrative-focused games. And I'll tell you a little bit about our approach, right? So we took a grounded approach, and we invited a number of game designers or narrative designers to work with us to provide feedback. And then we identified a number of common tasks in narrative game design and created prompts for them, worked over, made an iteration on the prompts, then created a whole spec sheet, and we see that as the beginning of a benchmarking framework, and we plan to update it. So, I mean, way too much material to present, but there's a big archive with 248 outputs, so you can look at it yourself. Here are some examples of the outputs, and I don't really think I have time to go into that, but some things were rather convincing and interesting that came out of it, but most of the stuff was not really, in the strictest sense, production ready. And in particular, it struggled with creating anything that was truly interactive when it came to narrative. It made convincing storylines, but when we asked it to have important branching points that really went into interestingly different directions, there was a real struggle. So Jhane AI can't do interactive narrative for the most part. And we had the results evaluated again by industry experts, not only by us, by practicing game designers. Michael Anderson works at Paradox Interactive. Frederick Serafina, Square Enix. Emily Short is I think, a very well-known independent in that field, right? And but she says, for example, mostly that these things maybe can use for training, for ideation and training, but are not production ready. And that is kind of like, what all of these game designers said. Too verbose for direct use in production, for example, right? A bit underdeveloped, I could use that as inspiration, right? So this is kind of what we see from here. Of course, you can read more in the whole paper. But in order to get to this detailed understanding, we had to create a benchmarking framework, right? And that was important because there isn't any, right? So when you look at generative AIs, there are benchmarking frameworks for them, but none of them are about, let's say, narrative design or game design. And they look like that, right? And they allow, a computer science expert to say, this is DeepSeek in comparison to OpenAI, and okay, right? So what I'm basically suggesting here is that we need something like that for games, right? And I'm very happy to announce that Ardin and Hefka are working together to create such a thing, right? And we hope, it will, the starting point was this paper that I already showed, and I will hope we have more this summer. And that's what we are kind of doing right now. And of course, I'm more than happy to have more industry input on this whole process. But I think that would really help to have something that allows us to look at things. I need generative AI for, advanced pathfinding. What is good at that, right? Okay. We should also be very much aware of the limitations and ethical considerations. Here were some reactions that I got when I posted our questionnaire from this effort. I need more than 1 minute to finish this. Sorry, not going to happen, right? So, I was basically thrown out of a Facebook group because of that, right? Or basically, I had to try to take it down, and, you're not going to help us to make us redundant. I'm like, I'm trying to understand that. I'm an academic. Okay, so, but I think it's understand the capabilities, limitations, ethical problems of Gen AI is crucial, right? And of course, if you haven't been on Hugging Face, you should be on Hugging Face, right? Hugging Face, if you don't know, is a wonderful platform to compare different generative AI tools, right? You find DeepSeek there, you find Llama there, they're all there, and with different applications. So it's a blunt place shop for trying out a lot of things. And I mean, in a recent conversation I was on that topic, I mean, this was a sentence that stuck with me. You will not be replaced by AI, but you might be replaced by somebody who knows AI better than you. Right? So that should really be, I think, what most game designers should think about, right? Okay, thinking outside the box. I think we should all start thinking differently about games, right? The current generation is a paradigm shift for games. And what could that mean? Well, I mean, two things, again, out of academia, how to think about it. One is system building, right? And this is a paper I wrote with Miriam in 2021. Game system building, a creative artistic practice which foregrounds the consideration of complex and often unpredictable behavior that emerges out of the intricate combinatorics of dynamic systems, players' interactions. Right? So, I mean, of course, there's a whole paper about it, but we feel that current game design still embodies what we understand as mechanical thinking. Right? What comes out is the sum of its parts. And it's also embedded in frameworks like MDA and many production processes, right? But when we embrace systemic thinking, we embrace unpredictability, because that's a fundamental element of practice, the practice of building non-zero-sum games, right? So again, mechanical thinking is the sum of its parts. But system thinking more than the sum of its parts because of these unpredictable things that might arise. And that's what we get, and that's what we need to embrace, right? And, you know, this is what ChatGPT thinks this means. But, yeah, I will skip over that, but basically it's thinking about architectures, about generation, and about participation and performance. There's more about that in this paper. And another way to think about it, and that's from the PhD thesis that was just defended, is sort of paradigm of neurogame design, right? And Frederick says here, a future where games are not only played but also involved and co-created with their users in intelligent algorithms. And that embraces non-humancy as a foundational element of game design, advancing immersion gameplay as a key design paradigm and exploring the integration of affective resonance in AI-driven systems, right? And that's his PhD thesis, right? So what types of new games could come out of that, right? I think it's games that use AI as a material for co-creation. For example, NPCs with complex personality traits and emotions which can turn into long-term friends or enemies, right? The NPC that talks back, right? The NPC that has breakdowns and you need to think, what do I do as a friend, right? So much, much broader characters, right? But also player characters with complex personality traits that might sometimes be unable to control themselves. Oh, I shouldn't have done that, but, right? And develop in unexpected ways. Or environment which can change in profound and unexpected ways. So think sim-type games or real-time strategy games, but on steroids. Right? Where many more things change than just, you know, building a house and having an income or something. And, for example, also narrative-based games which can adjust to different cultural story structures on the fly. For example, Kisho Tenketsu, a Japanese story structure that doesn't have a climax, that doesn't have the tension build up, that has a twist and then an explanation how the unexpected twist still fits the rest of the story. Or many other cultural story structures, essentially where every tribe in the world has a story structure when you start looking. There is really no universality in this. And we could build games that adjust. That says, oh, I want to see that in a Namibian or African oral storytelling way. Or as a Bengali witness video narrative. Right. Of course, also games that learn what the player likes and adjust accordingly in much deeper ways than so far. And another thing that I find interesting, I mean, of course, there's a potential that game production becomes cheaper than it is right now. Right? And that also means games for smaller occasions, a game for a wedding, a game for an anniversary. So there is opportunity here, right? Whatever you can come up with. So wrapping up, AI is a creative opportunity. Again, as a reminder, video games and AI have been connected since the start of computation. And the current generation of generative AI makes AI advances accessible and enables exciting new games with deeper player agency and personalization, greater emotional palette, and dynamic developments. So this is the opportunity, right? Or as a graphic. And I think these opportunities require a rethinking of game design approaches from mechanical thinking to system building and neurodesign. But let's not forget there also come considerable responsibilities in terms of the potential for eliminating jobs, in terms of bias in data sets, and regarding copyright. And that requires a community effort to address. And I think for game developers, it's time to embrace the new tools and create novel, amazing games which represent our complex reality. Well, prop for my book if you want to know more about thinking differently about narrative in games. And that's it. Thank you. Questions? Can I just, how about if I bring the mic to the question? I mean, it's a wireless mic, right?
No, thank you so much. And I really appreciate the connections to systems thinking. And I'm more gravitate towards, because I'm an evaluator, so from the evaluative thinking perspective, curious as to the principles that are guiding your evaluation framework. Thank you.
Evaluation frameworks. Well, I mean, it was really a grounded approach, right? We really thought, okay, what do narrative designers in our case really need, right? And when we came up with a list of ourselves, and when we sent the list to our focus group of practicing narrative designers, and we mostly said okay, but then in the end we ended up with 3 more tasks. So yeah, it's organically built up from the ground.
How are you accounting for culture and context with that grounded approach? I think that's where the heart of my question is.
We're not there yet, right? It's something we need to do. I mean, of course, if you look into my earlier work, you will see that I've spent quite a bit of time on thinking about what I mentioned, narrative structures in different cultures, right? And of which are plenty, and there's actually not enough work done on that. For example, one of my dreams would be an army of PhD students in Africa actually giving us these structures. Because what we have when it comes, for example, to African oral storytelling, we have collections, we have recordings, but we have no structural descriptions that a designer could simply implement. And when you start digging, it's difficult to find. Right? So there's ample opportunity for that, and I mean, I have a paper, if you want to look it up under my name, from 2018, the Myth of Universal Story Structure, and that I wrote with 4 master students, and I gave all of these master students a different geographic region, and we all found easily many structures, and some of them you see there. Okay? I'm here. Just find me. Thank you so much.
stream. You picking up audio? All right. Welcome back, everybody. If you're on the stream, hello. Again, we talked early on about how events like this are great for building communities, and our next speaker actually reached out to me essentially through those communities. She's active in the game development communities here in Atlanta, and that's what I love to hear. People spreading word, hey, you need to go ahead and speak at Transformer, and her reaching out through these networks that we're already building and we're expanding on. At some point today, I'll be sharing the GGA Discord with you. Usually the Georgia Game Developer Association Discord is only for GGA members, but we're starting a Transformer AI channel within that server, so I'll be sharing that with you as the day goes on. But I really enjoyed having Eleanor reach out to me, and with her specific topic, it's our feeling that the ethics in AI, in Gen AI, is really still in its infantile stages. The discussion around it, the results from it, and so forth. And it's key to all of what we are doing with AI now. What we do with AI now, I've been an AI designer since the mid-90s, and what we do with AI now is very different from the work I've been doing for decades. So it was great when Eleanor reached out to me with this. She's already active in the communities. I believe you've already been to Insomniac. You're going to head to Insomniac for a bit? This summer with Insomniac. In fact, one of my first programmers, Garner Holleround, who worked on Earth Fading Suns, which I'm plugging repeatedly today. Our lead programmer in The Fading Suns is now one of their main game engine coders. So it's great how the game development community builds. But these conversations in ethics, from the very biggest pictures to the little tiny hairs we still need to split, I think are key, which is why I was glad that she sent me this proposal and we placed it as our second presentation today. The conversations about ethics are key. Handling them as an informed, intelligent community is key, and presentations like this are key. So thank you very much, Eleanor.
Oh, thank you. Well, I guess I want to say thank you all so much for the opportunity. I'm really excited to speak to you today about our work so far. So I'm Eleanor Buvel Mather, and I'm an undergraduate computer science student at Georgia Tech. And I'm working with Professor Neha Kumar at the Tandem Lab at Georgia Tech. Well, she's the head of the Tandem Lab at Georgia Tech, and I'm being mentored on the project by Vishal Sharma, who's a PhD candidate, and Pejman Mirza Babe, who's consulting us from the Ontario Institute of Technology, and he's an expert in the game development research space, so that's been wonderful as well. So I'm very grateful all around. So as has already been discussed a little bit earlier, generative artificial intelligence sort of promises like an automation of creative tasks, but it also raises concerns about being replaced, like the thought of human creativity being replaced. There are anxieties about that, and there's research has already been done on game developer reactions to these tools, but we're going to be extending this research by looking at the larger ecology of workers in game development. So not just programmers, also programmers, designers, artists, and writers, sort of seeing the interaction of all these different types of work and the types of tools that they use and or react to, that sort of thing. So generally, our research questions are: how do workers involved in the game development ecosystem perceive the increasing integration of generative AI into their workflows? And how might their creative capabilities be responsibly supported and augmented via generative AI? In short, how might generative AI be designed to mediate game development workflows in ways that are most helpful? I guess I'm going to talk a little more about myself. Okay, I'm in the back here. That's the, so I participated in the local independent developer community. I've been on leadership and I've been a team lead of Georgia Tech's video game development club in the past. And I've kept in touch with alumni who have moved on to the industry. I've also participated in ATL game dev community meetups to sort of keep my finger on the pulse of what's going on around there. And those are great fun. I recommend them. Everyone's very friendly and kind. And I've personally noticed, different opinions and anxieties about these tools, and it's sort of hard to parse, there's sort of, it's hard to parse, if everyone, it's hard to parse, in a group setting, what anxieties are more generalized, or what's just hype and what's actually useful to people, that sort of thing. So I wanted to, ask people specifically and get their insight on the perspectives of people who work on games and would be asked to use these tools and how they are in practice. So our methods, we're conducting surveys and interviews with game developers all over North America. So through the survey, we're collecting data from like a broader audience, and we're also using it as a screening tool for more detailed interviews. Those are semi-structured interviews. And we want to examine the developers' perspectives and use of generative AI, as well as responsible ways to integrate it into the game development ecosystem. Before I move on, so these are preliminary results. We've done about 11 interviews so far, and we've begun the qualitative analysis process for around the first half of them. But as we get more data and as we look at the data more, with the way theming goes, is that sometimes you get more context, and you think something goes into one category, and we might have more specific details and results later on as we get more data. Okay, well, thank you so much for your patience. All right, so I guess I want to start off with some of the positive changes to workflow. So generally, when people have used generative AI and they found it to be useful, it's usually during like the brainstorming process or the conception process, especially with independent developers. Solo devs especially enjoyed sort of having the support that would normally require another person, and if they were going to work alone anyway, these tools have been helpful. Generally, there's a focus on, it's either easing some of these tasks or it has made the process all around faster. And then there are also negative and neutral impacts on workflow. So there are still some occasions where, especially with image generation or like asset creation, where let's say, for example, you want an image or an asset to work in a very specific context in a game. A lot of participants sort of find that, I want this 2D image to fit this art style, and they constantly get, a 3D rendering, or they get something in like a slightly adjacent art style, and it takes longer to edit it, that sort of thing. And similarly, with some programming tools, a lot of programmers reported that, specifically using tools like ChatGPT to help with programming problems that they would have looked up on Stack Overflow has been very helpful, but like code generation tools like Copilot can be hit or miss, where sometimes it can hallucinate and sort of get in the way. So there's been mixed results in that regard. Also, among participants who did or didn't use generative AI tools, of course, as has already been brought up, there are a lot of anxieties and ethical concerns about the implications of some of these tools in terms of like job environment and how jobs might look different. And actually we get more into that in one of the later themes, is that even among people who use tools and enjoy using these tools, there's sort of a lot of individuals sort of create ground rules for themselves. So it's like sort of like, I use generative AI tools for X, but I would never use it for Y. And there's sort of this idea of, I want to make it clear that I wouldn't use it in a finished product, or some participants are like, I wouldn't use it for creative work. So there sort of tends to be like ground rules that have started to be made, though everyone has a slightly different idea of what those are, like what they're comfortable using and what they think is useful. In particular, artists, especially artists who worked on independent, who work with indie devs, are often, they usually do commissions or do individual work outside of it. They sort of have had trouble keeping their portfolios public due to data scraping in the environment. So a lot of artists have sort of introduced like glazing all their artworks into their workflow. So now all of their artworks have that filter on them. Similarly, there's sort of anxieties about what might be done with their art. For example, one participant talked about how, an artist died and immediately someone made like a model using that artist's art style. So there are new concerns about, not just, someone will copy and paste a commission I did and then say it's their own. It's like, someone's gonna make a model off of my work after I die. Like there's sort of a different higher level of anxiety around stuff like that. I will say some participants have been in the position where they sort of can hire people, and apparently there's sort of a shift in artist attitudes towards if a job explicitly says they won't use their art to train it seems to be that it's a given. Some artists see that it's a given that their art may be used for some of these models, and they're a little bit concerned about that. So there's almost a sense of relief when there's something in the contract saying that it won't, or if they would get compensated for it. So there's definitely a change. There are more anxieties and more things that artists have had to think about, especially in independent development. Though we have heard from some participants who work in like AA and AAA environments where they're sort of being encouraged to implement these tools into their workflow as well. Though we haven't gotten as much data on that so far. So. Also, speaking of anxiety, this is sort of anxiety outside of the context of, job-related anxiety. It's like even among users that use it often, there tends to be this thing where they may use it, but they say, like, outside of saying, oh, I use it for this, but not for that, there tends to be this anxiety about, oh, I don't know where it's going to go. I don't know if it can do this. I wonder if it'll replace this task. And then similarly, in a different vein, actually, some people who use these tools are sort of afraid of saying that they use it because they're worried they'll be, let's say, for example, someone might use the tool for like concept art or to help them brainstorm, and they're worried that if they say that, someone else may assume that they use it like in their finished product. And especially since a lot of independent developer communities are online, they're worried about online harassment, among other things. So there's sort of an increased sense of anxiety in some communities, especially independent developer communities. So of course these are just preliminary findings, and I'm really excited to look at more, to interview more people and look at more of the data. So we hope that like this exploratory research will contribute to forming a deeper understandings of more responsible ways to integrate generative AI. I think our goals are to sort of, if we're going to use these tools, it's best to use them in ways that are most helpful to the people that are going to use them, and that really not only sort of makes things more efficient, but also sort of makes, because if people don't, it's a lot of, sorry, I'm stumbling over. So I guess we want to make sure we integrate it in a way that doesn't feel haphazard, or, oh, we introduced this tool and, oh, half the team doesn't use it because it gets in the way of what they're doing, or half the team doesn't even want to use it because of this, or it's best to understand how people are going to react before introducing these things. I want to thank Vishal Sharma, the PhD candidate in human-centered computing, and the Jhane Lab, who taught me where to begin with conducting this research project. I want to give thanks to Professor Pejman Mirza Buvel for bringing his expertise and insight on game development. And without Professor Neha Kumar's advising, I would definitely not be here right now. And I would love to hear feedback from all of you, from you all moving forward with this research project. We've conducted 11 or so interviews, and our goal is 15, but like more would be amazing also. So if you have any advice on recruitment, or with conducting interviews and things like that, I would love to hear it, or any other comments would be amazingly welcome. Also, I do have, if you know anyone who would like to take the survey or participate in the study, feel free to forward their contact info to me if that is quite all right. Yeah, but but I'm totally open to questions, and yeah, I hope I haven't, well, thank you so much again. Oh, yeah.
So it seems that you have examples where the communities are sort of self-policing and hating people out that are using it. I wonder if those people are forming their own AI positive communities.
Oh yeah, that's a great question. So the question was, since there's self-policing in communities, are people who use these tools creating their own sub-communities where they may be able to talk about using these tools freely? I think it's been tricky, because I think a lot of people who use the tools and are worried about talking about it tend to be in much smaller teams, if not teams of one, and they tend to. It seems to be there's definitely the atmosphere seems to be, oh, I talked to this person who I trust, who is a friend of mine, as opposed to, oh, I post about this online in this forum. Though it's definitely something that I'd want to ask more about moving forward. I think it's tricky because a lot of the participants were pretty open about their use depending on how they used it. It's sort of like, it's definitely, it's hard to gauge with the amount of participants we've had so far that have had that experience, because it's been, yes, but that's definitely something I want to keep in mind. So thank you for asking that.
So I'm curious. I see a lot. There seems to be difference in views on AI depending on what you work in. So, for example, programmers, at least what I see, tend to be more supportive of it. Visual artists tend to be a little less. Have you noticed that in your interviews that different types of creatives have different views as group, or has it been more varied?
Oh yeah, that's a really interesting question, and it has come up before. So the question was like, oh, do different workers in the field have different perspectives on generative AI? Like, for example, are programmers more receptive or artists more receptive? Something I found that was sort of interesting is that, like, among both artists and programmers, at least so far, is that their opinions on generative AI were relatively consistent, but it was sort of like, oh, an artist may say, oh, I think it's pretty okay if a programmer does it for this, but I don't really want to use it for art. And a programmer may say, oh yeah, I use it for programming help sometimes, but I wouldn't use it for visual art. And then someone who uses it for a little bit of everything may say, oh, I'm fine with using, like, it doesn't necessarily, there didn't seem to be too much of a difference between roles necessarily. That was interesting, but there was a trend where people were more okay, like people who didn't want to use these tools for visual art generally were totally okay with it being used in programming, and vice versa. So I thought that was interesting, and I appreciate that question.
Do we have any other questions? We still have some time. Okay. Well, thank you so much.
Oh, thank you so much. Also, thank you so much thank you so much for having me, and I'm excited to see everyone else's presentations. Okay.
Hello, everyone. So we now welcome Nick Murphy, who's a lecturer in game design and software engineering here at KSU. And today he will talk about leveraging open source AI in game asset creation and editing.
All right. Well, hopefully. We'll see if the PowerPoint will load. But while I'm waiting for it to decide to start working, how many of you know what open source is, or heard that term before? All right, good. Last time I gave this presentation, no one did, and it was a little uncomfortable. So there we go. It might start up. We'll see. There we go. All right. So for those of you who raised your hand, but you actually don't know, you just don't want to feel left out, the idea of open source is that rather than hoarding all my source code away from everyone else, I put it online, and I even say, hey, if you can improve on this, submit code, and I'll incorporate it. And a lot of software that we use runs on this. So for example, anyone use Blender? Open source, right? Anyone use Krita? Open source. Firefox, Linux, tons of things are open source. So AI is being incorporated in a lot of commercial products, right? Anyone use Photoshop? Yeah, of course. So a lot of commercial products, a lot of monetization there. For example, things like Adobe Firefly is one of their big pushes to incorporate generative AI into artist development processes. But there are some concerns. For example, oh, gotta stay here? All right, my apologies. I like to walk the stage, as some of you who are my students know. I'll try to minimize it. So for example, do we know where that data comes from? Adobe was kind of cagey about it, but they finally admitted that they pulled some of it from Adobe stock and some of it from Midjourney, which they didn't want to admit. So there's concerns about data, especially if you want to release something. You may not have the rights to it. There may be some issues, as has been brought up before. You may also be worried about versioning. So if, for example, a while back, Photoshop ran into issues where they temporarily had an issue with a partnership with Pantone, and so people who had Pantone colors opened up Photoshop and they were all black because it had been taken out because it's a cloud platform. So if you're worried about that, which you might be, you may want to have more control over your data. You may also not be able to afford the licenses for more commercial software. And again, ethical and legal concerns. So one of the things I want to talk about today is AI generation incorporation in open source software. So rather than having to rely on commercial software, there are plenty of uses of AI in open source. So these are either built into the applications already, or you can install them via plugins and extensions, right? So you have that option. If you want no AI, then you have that option. If you want to incorporate AI, you have that freedom. One of the benefits of open source, right? Also, you have the ability to review your code and your data sets. So last I checked, I can't look at Photoshop's code, right? I can't verify that it's not doing something I don't want or something that might get me in trouble. But with open source, by definition, I can. I may not actually do it, but I have that freedom, right? They tend to be free or low cost. So again, if you're an indie studio, you're just starting out, or you just at the moment can't afford the licensing, free software, pretty good. Now there are some trade-offs, right? Maybe the usability isn't quite as nice, as polished, but for free, might be willing to put up with that. And also, you can stand in a particular version. So if I want to keep Krita a particular version, I don't have to worry about the owners of Krita saying, nope, cloud platform, you're going to update to this new version that takes out this feature that you use. You can stick on that version. If you really want to, even if they remove it from a future version, you can get the source code from an earlier one, build it, and keep running it as you like. So you have that freedom and that control. Right? I'm not being paid by open source to sell it. I'm just explaining. So here's some common tasks, and I'm focusing primarily on art and art asset generation, but there are obviously for music, for video, similar concepts. So some things you might want to do using AI are image segmentation. So if I have a texture, I have an asset, and I want to change a particular part, I want to be able to very quickly do that. Use AI to specify, oh, this is a person, this is a camera, that's a trash can, rather than having to do color select and other things like that. And there are AI algorithms and tools that are built in that you can use. I might also want to upscale. So if I'm doing a remaster, or if I got a really low quality image, I may want to be able to upscale it without having to redraw it. So there are plenty of non-AI algorithms to do that, but also a lot of interesting AI algorithms that will guess what a larger version should look like. We also have in-painting and out-painting. So let's say that I have this texture that an artist gave me, and now I want to expand on it. I might be able to utilize tools to guess what should be in there. So for example, if I'm only seeing this much, I can use out-painting to guess what the larger space would look like, again, using AI. In-painting is the opposite. If I have something that is, I want to get rid of a particular texture and it's really tightly integrated with the scene, I can use in-painting to fill in the spaces. Right? And then obviously asset generation, and there's all sorts of different possibilities there. So I'm going to go over a few of these and just show you some examples in open source of how these are used. Keep an eye on the clock. So I'm going to start off with an older one, relatively, which is the resynthesizer. So this is a plugin for the open source software GIMP, which actually existed before Photoshop's version of it, which they are super proud of. One area they beat them in. And the idea, this was based on a dissertation from 2005. And so the idea is very simple. When I look at an image, rather than just learning boundaries, I can also learn the textures. So for example, those chairs are different colors, right? The seats, but they have the same texture. And so if I learn the textures of these areas and then I see other textures look similar, I can fill them in, right? And so that's the idea of their synthesizer. It is a very relatively basic algorithm compared to some of the more advanced ones. It only trains on a single image. So if you're worried about copyright, your synthesizer has no issues. It has no data set other than the image itself. The trade-off is that, well, you can't generate something from outside the image. So if you want to make a frog appear in there and there's no frog, you can't do that because it's not in the training set. But again, if you're doing editing on a texture, you want to clean something up, it can be a useful tool. And so I will go ahead and show you a brief demo of me. This is an image I was playing around with. I incorporated the synthesizer. And so what you will see, just messing around with some of the settings over here, how it pulls the information, looking from the sides, doing randomly. And so we see that I am circling this child because I want to get rid of the child, because I'm a terrible person. And look, they are gone. Magic. Again, so I can run it a few times because I may not like the outcome. It will randomly generate a little bit differently each time. And again, this is not as advanced as some other models because it is only using the data that's around it. So I don't have a large training set, but on the bright side, I don't have to worry about copyright issues. I don't have to worry about I'm training on some data, I'm using some data that, stealing from someone else, depending on how you want to define that. So, all right. So that's an example of in-painting. Now, there are plenty of other more advanced algorithms. So for example, somebody mentioned you used Krita earlier. And so Krita has several plugins that can connect to Stable Diffusion or to local models, which is an interesting point. So rather than pulling from online and having possibly licensing, if I have a local model that I have installed on my computer, I can use that as a source instead. So I have more control over that data. If I've already have a model that's been trained on images that I have the rights to or on public domain, again, I don't have to worry about so much the copyright issues. So these plugins, and GIMP has them as well. Intel has demoed some plugins using GIMP. But they have a variety of features, including the upscaling I mentioned earlier, in painting that we just saw, and out painting, as well as asset generation, right? So I'll show you a demo of that I did not do, but I have from the interwebs. So if we look here,
should be in the lower section of an image.
And I'll go ahead and turn the volume off because they're not the one talking, I am. All right, so let's see, is it running? It is not. I thought it'd be clever by downloading in advance. It seems, there we go. All right, so kind of hard to see, but there is a prompt over there describing a house, and you see that as they draw, over here, they're generating something based off that prompt, so like a field with a blue sky. And so it's based off the sketch they've drawn here. So they have some artistic control of where the field is, and then they can control the strength of how much it has an impact. And so then we're going to change colors again to a blue sky, and as they draw, we'll see that the image over here fills in with clouds. It goes to a more blue area, creates more of a blue sky field, and then there's a checkbox over there. They're going to do some more coloring in a second to create more of a shiny sunset effect. And then when they're ready, they can click the checkbox to bring the generated image, the generated asset, over to here, which they will do in just a second if I remember this video. They can also alter their prompt, so they can, for example, add information about I want to add a house here, I want to add other assets, with a nice arrow showing it off. So I'm going to give them just another second to show that before I move back to my own part of the presentation, because again, this is supposed to be my talk. And so this can be a workflow if you're generating textures. See, there you go, pass it over. And then again, they will add some information about, now I want to add a house to this scene, or I want to add a house to this texture. And so they'll start drawing over here, and that will generate houses over there, or they can do it automatically. But if you want to have more control, this can be tied in with an artistic workflow. Let me give them just another second. So see, as they're drawing over here, now the house is matching their drawing, right? So there's still some imprecision compared to if they had done this all by themselves, right? But they can influence the generated asset. Now, the trade-off, mentioned earlier that with Resynthesizer, no copyright issues. If you were pulling this from a standard data set, you might run into some challenges there, and we'll talk about that in just a little bit. All right. So Blender is another tool that has integrated AI assets. Blender has a lot more funding than both GIMP and Krita, so they have a whole plugin workspace. Some of them are paid, some of them are free. But they have a variety of features, for example, text to texture or to PBR. So if you have a model that you want to generate a texture for, you can type in just like we saw with Krita and generate that texture, play around with it, export it possibly into the art program to do editing or using Grease Pencil or something like that. They also have tools like AutoDepth AI, where if I want to make an environment or scene, I can take an image, pass it through the filter, a 2D image, and make a 3D scene out of it. Now again, as was kind of mentioned in our keynote, you may have to do some work on that, right? With 3D models especially, well, anyone ever done a 3D scan of something and then tried to use it in a game? So is that something right off the bat you can take that? No. So that's still something where it may look right until you look at the geometry and it's just a mangled mess of things. But you have maybe a starting point, right? Other examples that I thought were pretty interesting are a render refiner. So if you have some sort of effect, like maybe a simple halo, you can use Blender AI plugins to analyze that and say, hey, I want to make this more of a multicolor render. I want to do this. So you can play around with your rendering pipelines. All right. So I thought I'd take a pause for a second, because I've talked about all these applications, and I'm not going to go super deep into lecture for those of you who are worried about that, but I do kind of want to give you an idea of how all this works at a high level. So a lot of these image asset generations use something called a diffusion model. And so the idea of diffusion is that I can learn about something in various stages and then reverse that effect and be able to generate it. So let me show you visually what I'm talking about. So let's say I start off, I have this photo, and I've tagged it and I've said, hey, this is a photo of a man on a bike driving through the countryside, right? So in my model, I will do something called adding a little bit of noise. So I will go here, and I'll add some noise. Part of it's covered up, a little more drastically than in real life. And I'm going to relearn it again. I'm going to say, this is still a picture of a man on a bike driving through the countryside with some noise. I'll train it again. I'll put some more noise in there. Notice how the image is becoming less and less immediately visible as a man on a bike. But I'm still saying man on a bike with a certain amount of noise. And I will keep doing this over and over again until eventually, let me go ahead and do this real quick. Eventually, at the end of my training cycle, I will put so much noise in there that it's just that, right? So that's step one. Then I reverse the process. I train it again. I say, all right, I want to make man on a bike. Let me remove a few bits of noise. Let me do that again. Let me do that again. Let me do that again until I get back to my original image. And so what the model should learn, obviously not with just one image, but a whole bunch, is, hey, if I have a random Gaussian distribution just of noise, of random stuff, and I want to make a man on a bike, these are the pixels you remove and change to get this image. And if I do that a whole bunch with a whole bunch of images that are labeled very well, then I can generate assets, right? And so the idea is that if I do this with enough images, it won't be necessarily specifically this man on a bike that I get back. It will be some amalgamation of all the men on bikes driving through the countryside that I have trained on. However, if I only trained on one man on a bike, I'm going to get this exact image back. So that's where some of the copyright concerns come in terms of the data, the image you're getting back out. How much is it like the original image it trained on? I'm not going to be able to solve all those questions today, right? But hopefully at least you have a better understanding of how it works. And again, a lot more math involved, but I won't torture you with that today. Maybe. But conceptually, that's how all of these work. And they're often combined with other models. So for example, just a diffusion model would just be the training, putting the noise in there, getting it back out. Mostly you want to combine it with things like a text image, so it knows if I ask for man on bike, it knows what man on bike is and how to get that back out, right? Otherwise, I've just made this amazingly beautiful picture. So I mentioned image segmentation. Facebook, which was mentioned earlier, has released an open source model called Segment Anything 2. It's open source, and a lot of open source software incorporates this model. And so the idea, again, is that based on a whole bunch of images that it trained on, it can segment, oh, person, gimbal, camera in back, skylight. And so if it sees an image with that and you ask it to segment, it will be able to do that almost automatically. So rather than having to select colors or do masking or something like that. So again, very, very helpful if I'm trying to do some asset editing. All right, so was already brought up earlier, and I'm going to make some notes here as well. I showed you with the diffusion model potential ethical concerns, right, using copyright data. To train a model, you can't just use one image. I know, that's very sad. It'd be nice if we could. You need a whole bunch of images. You need a whole bunch of data sets, and I don't know about the rest of you. I don't have time to go and draw all those many images to train. Maybe some of you can, in which case you have a bright career in data entry. But so in most cases, we tend to train on existing data sets, right? And that's where the rub comes in. If I use a data set that I'm not aware of, every image that's in it, can I 100% say that I've used only ethically sourced, copyright-free images? I probably can't say that with certainty. In fact, one of the first really big data sets, Leon 5B, was found to contain all sorts of terrible things. It contained, for example, people's medical records because it just hoovered up the internet. It also contained child porn. So initial models that trained, stable diffusion, thing like that, trained on child porn, which means they can generate it. So a lot of concerns, right? Again, I'm not going to say any of that was intentional. The billions of images were needed to do the initial training sets. To get those kind of images without paying someone a whole bunch of money, you kind of have to hoover up a bunch of stuff undiscerningly. Right? So I'm not necessarily saying any one person was evil, but just by the very nature of what they're doing, things like that slip through. Other thing to be concerned about is that oftentimes when companies say that, we only used our own images, what they actually mean is we used an existing data set as a base and then fine-tune on it with our own stuff. 5 minutes? Okay. All right. So that's something to be cautious about. I mentioned earlier, Adobe originally was claiming they only used Adobe stock, and then it came out that actually they had trained on top of Midjourney. So in terms of copyright, that's still an ongoing thing as mentioned earlier. There have been some early cases settled that are not using generative AI. Router, I think, was one that was trained using an earlier type of rule-based AI, and that was decided in the favor of Router. So I'm saying it wrong, but in terms of the original creators. So far in the US at least, there has been a tendency to lean towards the creators' rights. We'll see how that goes as the court cases go on. There's still several outstanding. But also studies have been done to show that artists are still needed for high quality products. I've seen plenty of examples both as a teacher and working in open source and in game design of people submitting AI generated stuff, and then when you look at it for more than a second, you're like, oh, well, there's problems here and there's issues there. So people with that knowledge are still needed to ensure that what's generated and produced is high quality. So again, some relevant cases. Most cases tend to be from 2020 onward. AI existed long before that, but the current generative AI really started becoming well known around then. So again, that was one I mentioned earlier. One of the big art ones is Anderson versus Stability AI in terms of, again, claims about using their images without permission in the training set. That's still ongoing. And then the U.S. Copyright Office one is not so much a court case. It's just this particular person keeps submitting AI-generated comics for copyright, and they keep rejecting it, which is kind of amusing. Essentially, the Copyright Office has said, you own the rights to the positioning of the panels, you own the rights to the words, you don't own the rights to the image. So again, that's the current state in the US. Different countries obviously have different rulings. I know in the UK they're having some heated discussion about that. So just something to be aware of. All right, so as I wrap up, just some best practices, recommendations. Know your data throughout the chain. So if you don't know what data you're using, if you're not using a local model, you are potentially at risk, right? And I know that's not easy. That takes some work. It's worthwhile. If you can, also get licensing agreements. So if you are getting data provided by someone else, get a license saying, hey, you're telling us that this data you have the rights to, we can use. That way, if they're lying to you, well, you have signed documents saying, hey, not my fault. And then also just be aware of your tools. So with open source, you can audit your code. I know that's an effort that takes some skill, but that is something you have the option to do with open source. I encourage you to do so. And if you can, run locally. That's not always an option, but again, if I'm running a model locally, I know all the data, I know where it's coming from, pretty much set. So that is my quick overview. Covered several different topics. So now, any questions? Cool. Oh, wow. All right. Usually I make my students do rock, paper, scissors, but I saw you first, so let's go for it. Yes, you.
I guess mine's more of like a rudimentary question. I guess how are you building your own local data?
So that is the rub, right? You can build them with public domain images. So there are plenty of repositories with public domain as a starting point. I can't draw enough images to make a really comprehensive data set, but there are plenty of public domain that you can build off, and then you can use your own work to fine tune. Now again, training a model takes a lot of resources. You can, for example, use Google to train it for you, so you can take advantage of the resources. It costs some money. But that would be my recommendation and starting point, public domain. The challenge, again, is that if something's not in the public domain, well, then you either have to draw it yourself or get licensing rights for it. And that can be another approach. For example, some companies who already have a wealth of images that they own, for example, Disney, they don't have to worry about that because they can just license their own work, right? But it's a challenge. That'd be my starting point, though. Public domain, something you can verify you own the issues, data for, and then build from there. All right. Yeah. All right. I saw their hands. I did. And I saw yours next. All right. I'm going completely off screen, but it's all right.
No problem. Yeah, so my question is, the first part was similar to hers. I think it's going to be really difficult for me to grab a bunch of public domain images off the internet because they're going to be claiming they are public domain too, so that's a problem. What is the current state of open source models that have been properly vetted by the open source community, which has historically done a good job at removing copyright from open source code, for instance?
So I will say that actually a lot of open source code is licensed. So it's a little bit different than it's not that they don't have copyright, it's that they're saying we license it and we're letting you use it for this. However, there might be some restrictions. So I would say that Creative Commons is kind of taking the lead on that. Creative Commons is kind of the open source art licensing model where you say, hey, I've drawn this thing and I am totally okay with you using it for this, this, and this. Not this, but this. So they have been doing a lot of work with trying to use Creative Commons images to build these local models. But again, it is something where It takes a lot of work, it takes a lot of effort, so it is still ongoing. But yeah, ideally, they're the ones kind of leading the charge in that, and so my hope is that as they continue to work on it, we will have these open source data sets that we can use. And again, with the tools I mentioned, they also allow you to use your local models. So if you have built one, you can use that instead. We're on the front here, future of games. All right, other questions? Yes. I should have planned this so I wouldn't have to run so much.
Exercise Saturday. So you focused on 2D images and still images. Do you feel a lot of this applies to 2D animated and 3D animated, especially folks around denoising?
No worries. Yes, so I only had so much time. I would have talked about a whole bunch of stuff if I had more time, which is always the case. But yes, so there is a lot of work being done, for example, on animation and keyframes. And for example, OpenToons is another software that has tools like this for animation keyframing. So I just didn't have time to talk about it. But yes, everyone's exploring it. Blender has 3D model generation. Audacity has various plugins in terms of generating sound. So anyone who's doing open source, there are people, either the official developers or people who are using those toolkits as a starting point to develop those plugins. So, All right. Yes, one more. All right. Maybe one more.
So I guess my question is a little bit multi-part. Okay. So first one is like, what kind of all goes into making your own local model? Because I know that there's like a lot of concerns about the amount of energy that it takes to train a model. Like there's like whole data centers that exist for that whole purpose. Is it a lot easier to train your own local model, or is it what is that kind of like?
Oh, sure. So anything's easy if you know how to do it. Yeah. Yes, that is a concern that hasn't been brought up, but anything that you train takes a lot of energy. However, it also depends on the number of generations you do. For example, in the research I work on separately from this, we are constantly retraining our models with new data. So we have pipelines where we generate certain data, we then retrain our models, we fine-tune it. Versus if you say build a local model as like a starting point, you may run that relatively few times. And you can, even if you have a good enough computer, run it just locally on your machine, and if you're just willing to wait a long time. So in general, you generate a data set, you annotate it. So I say like, oh, this is an image of man on bike in countryside. And obviously, the better you annotate it, the better results you're going to be able to get, right? If I just say man, I'm not going to get the information about bike or countryside, right? So there are whole jobs involved in people paying you to annotate images for AI training. So you generate your data set with your metadata, and then you pick your model, and then you essentially say, all right, here's my data loader. I'm going to say this many batches, so I might do 10 images at a time, 20 images at a time. I feed it through. I let it go for a certain number of cycles. So I showed you earlier with the diffusion model, it was color gradually adding and loading. So that might be one epoch per image. I may repeat that process more than one time. I probably will have to, in fact, because I don't want to overtrain it or undertrain it. Essentially get it sorry, I'm getting into teaching mode. I apologize. And so then at the result, I will have what's known as a set of weights. So the model essentially says, oh, if I give it this prompt, go through these various pathways, and the weights will say, this one's more important, this is less important. And so that will be combined with the actual algorithm to say, hey, to generate this kind of image, do this. Versus this image, do this.
And
so
at that point, it's just general neural net stuff.
Yeah. Okay. So yeah, once you the weights are the important part. That's the end result of your model training. And so if I want to draw in the style of Picasso, that would be one set of weights. If I want to draw in the style of, I don't know, Garfield, then that's a whole different thing, right? Okay, and I think I've run over my time, so. Oh. Have I run over my time? Okay. Well, all right, let's run over here. No, I did it for everyone else, and I don't want to single you out, I do. All right, so ask your question again.
Yeah. So what kind of hardware do you recommend for training a model?
So you'll need something with a GPU, not like an integrated one like you get from like the Walmart computers, because that's really, really important. With a GPU, with a CPU, I have to do everything one at a time. I can do a lot of complex stuff, but I do one at a time. With a GPU, I can say, hey, every one of you do this one simple thing and get back to me. And so rather, that allows me to do things very quickly. So if you get some GPUs, you can compensate. But in general, if you have a little bit of funding, use Colab or something like that, where you can just say, hey, Google, you have a whole bunch of stuff. I don't have to buy this hardware. I'll pay you a little bit of money to run my model and do it for you. All right. I'll let them have their mic back.
Thank you so much. So our next speaker, well, we actually have 2 minutes. If you all want to take a very short break, I think it's going to be appreciated. And then we're going to introduce the next speaker. Thank you. practice, building tools that support scholars, storytellers, and designers alike. Last year, he collaborated with game developer Kevin Markley to design an AI NPC environment for research communication in Unreal 5 that you're going to be able to test later today. So thank you very much, Dylan, and looking forward to your presentation.
Thank you so much. For anyone who's following along with their own laptop or following along at home, I'd like you to refer you to these slides so you can view the content in full resolution wherever you are. Today, I'd like to start with a comic from XKCD about machine learning. I think it speaks well to today's themes about noise and play. The purpose of today's presentation is to offer a rigorous, critical, and current state view of Gen AI and gaming with transformers and diffusion models. And my central argument today is that stochastic or noisy processes are not flaws, but essential creative engines driving innovation. And as a secondary claim, I assert that these techniques enable us to direct game projects with newfound facility and joy. I've structured this talk into 3 levels, covering the main ideas I'd like to communicate today. Each section pairs technology with concrete examples and broader implications for game creators and critics alike. Let me begin with a fundamental concept that will help us understand everything that follows. That concept is stochastic gradient descent, or SGD. Now, stochastic gradient descent is the workhorse of modern AI. It proves that randomness builds structure. Stochastic gradient descent, or SGD, is an optimization algorithm that powerfully demonstrates how randomness creates structure. And unlike traditional methods that process all data at once, SGD randomly samples small batches, calculates adjustments based on those samples, and iterates rapidly. Now, in many discussions about how this process works, the metaphor of the mountain is applied. And here's how many folks want to have you begin your adventure. They say, imagine you're hiking down a mountain in heavy fog with limited visibility, and you're watching your steps carefully. The first thing you do before you take a step is you kind of measure the steepness of where you're standing. Then you take a step in the direction that goes downhill fastest because you're trying to get off this mountain. And then after you take that step, you measure again from your new position, and then you just repeat this process until eventually you're at the bottom of the mountain. By trusting this partial an iterative process, a little bit recursive in nature, you often are going to reach the valley faster than hikers who are waiting around for the fog to clear, waiting for perfect clarity. And that willingness to act on incomplete information is part of our theme today, how we extract signal from noise. Now, the magic of SGD is that by embracing randomness, by using incomplete information, we often find better solutions than methods that try to be perfectly precise. And this parallels our central theme of finding that structure. Now, the only problem with this graphing calculator version of the explanation is it doesn't feel as though we've learned very much about how SGD works in the context of its real practice, which is very often in the service of neural nets. So to help you all today, I created a game just for this conference, and you can visit it if you're on a computer, not a mobile device, at this website, which we'll go to now, and I will demo this game that was made just for our group here today. 1 second. Okay, so the game is called Grandma's Television, and if you are old enough, you remember a television that looked like this. You might know it from the rabbit ears effect, where you would kind of adjust the rabbit ears to get rid of all of the staticky signal. And if you're playing at home along and you don't think it's staticky enough, you can just click that randomize static button, and I've got like a CSS like creating static over the image. Now, you see here we have these knobs on Grandma's TV. The knobs all go to 11, obviously, but we want to adjust these knobs to try to get the image clearer. So here I've made the owl a little bit clearer, and here I'm going to fiddle with this parameter too. I don't know which one's the clearest. What do you guys think? I want to see the face. Okay, so I'm going to come around here. Oh, it's getting very clear, and you can see here that the static rating of the image is going down. And my goal as the player is try to get it to 0. And ooh, I'm like bumping it up. Let me try to get it really low. Okay, we're getting really low, and we won. Okay, I've perfectly tuned it. Now, if I randomize the static again and I apply this optimization algo, you'll see that it'll self-adjust and find that for me without any kind of human interference. Sometimes it'll get trapped in a local minimum and have to rejigger some of the dials so that it can refine the lowest one. But it basically does what humans can do on grandma's TV with 4 dials. These 4 dials are 4 parameters, but like a large language model has many billions of dials, many billions of parameters, so to speak. So I hope this little game is something that you cherish as a little takeaway from the day. You can have it for free. Compliments of me. Okay, so let's move on from grandma's television and talk about some sources of creative noise. I've identified some sources here just to help us understand a little bit better, and I'll be talking about them in detail. So use this as a support for what I'm about to say. Now, the concept of noise in AI game development isn't just about static or unwanted interference. There are several different types of noise that serve as creative engines for modern systems. We have the Gaussian noise that's named after the bell curve distribution discovered by Carl Friedrich Gauss. It forms the foundation of diffusion models, as some of my colleagues have already alluded to today. And when diffusion-based image generation tools create assets or meshes from scratch, they begin with some pixels of Gaussian noise and systematically refine them to create a coherent image. Perlin noise is made famous by Ken Perlin. Did anyone see the original Tron movie? Yeah. So Ken Perlin designed the clouds for that movie, and that cloud technology he made for the movie, it bears his namesake. He won a technical award from the Academy for that, and it's pretty awesome that, you know, even though he made the clouds for Tron, 40 years later, we're still using his approach to build entire worlds. Now, unlike pure chaos, Perlin noise has some internal coherence to it. So instead of creating static in the sky, it creates something that looks like a puffy cloud. And games like Minecraft are using versions of that. Now, this third one that I have labeled RNG here, or random number generator, this is also known as mathematical stochasticity. This is very popular for games because it creates that illusion of chance. And even if it's not perfectly random, we as the player like to feel lucky, right? So that creates a certain level of drama. But we might also get noise from training data variance and prompt variability as another type of noise, right? That's inherently fuzzy. We'll talk a little bit about these kind of fuzzy sorts of prompts in a little bit. But I'd just like to point out that these sources of noise aren't adversaries to be eliminated. They're raw materials to be shaped. The art of denoising isn't about removing the randomness, but transforming it into something structured that retains a spark of unpredictability, that makes games engaging, makes environments feel natural. Okay, let's play a game. You guys know Jeopardy. Here's how it works. Someone's going to call out what dollar value they want, and then I'm going to read out the clue. Your goal is to guess the tool, or guess the system, or guess the approach, okay? So I'll tell you the input data, and I'll tell you what SGD is doing, and then you guess the system, okay? Let's start out for $100. The clue is, for $100, this system receives text as its input, and SGD learns to predict the next token from massive text corpora. What is ChatGPT? Correct, $100 to Andrew. Okay, for $200, Alex, this system receives image text pairs, and SGD learns to reverse Gaussian noise from images. That's right. What is diffusion? What is stable diffusion? What is Dolly? What is Midjourney? And we are up 300. I'd like that next one, $300, Alex. This system receives audio as its data input, and SGD learns mapping from audio features to tokens. Very close. Think the reverse direction. Reverse direction. Because audio is the input. What is whisper? Very good. For $400, this system receives low resolution frames and motion vectors, and SGD learns how to reconstruct high resolution frames. Very good, $400 over here for a DLSS. And for $500, this system receives images and camera poses. SGD learns the size and opacity of lights and colors for 3D scenes. Images and camera. Any ideas? I'll give you that last part of the clue again. It's used to reconstruct a 3D scene. You're close. Okay, no one gets $500, but no one lost $500, very importantly. The answer here is Gaussian splatting, or radiance fields. Very good. Okay, now we're on level 2. This is the asset warp pipe. Now, in classic game development, randomness was treated like a defect to be ironed out. Today, it's our raw material for creativity. Our models are beginning as a blizzard of Gaussian static. And we coax it step by step into a textured prop or a fully lit scene. And we might be using transformer-based generators to generate meshes for them, geometry for these objects, predicting these vertices as naturally as one might predict the next word with a language model. And leaning into stochasticity changes the economics of artistry for game making, quite frankly. One trained model can mint thousands of level variants at almost no additional cost. It gives designers a fountain of replayability that handcrafted maps can never match, at least in terms of scale. And more importantly, it keeps surprising us. Every fresh random seed is an invitation to discover forms that humans may never have the time to think of or may never want to consider in the first place. And the task behind us as modern game designers is not to silence that static, but to shape it, turn that raw noise into experience that players want to explore again and again. Enter Edify 3D. Edify 3D is a vivid example of putting this noise to work. I'm going to show you something, but first I want to kind of explain what that is. In this example, you're going to see a designer give Omniverse a text prompt. That text prompt is going to then seed a cloud of Gaussian static across a latent 3D canvas. And as the diffusion steps gradually tease shape from that chaos, a transformer will predict how each polygon should mesh with its neighbors. And within seconds, that fog will clear, and we'll have everything we want from our design environment. We'll want geometry, we'll want collision holes, we'll want lighting rigs. And crucially, we as the designer are not going to leave the loop. We're in control of this loop. We're going to nudge it in the directions we want, making adjustments as we fine-tune it. And this will take a minute or so to watch. Enjoy. Actually 3 minutes 30 seconds of work condensed down into a 45-second sizzle reel. And that's how quickly we can go from just the simple ideation to something we can work with, test with, kick the tires on. And I want us to think about, how we spend our hours in game development, right? Are we going to be spending all of our time tinkering with things that players may never see or players don't like, right? Are we going to be daring and bold and experiment and iterate faster than ever before so that we can keep players coming back for the next patch, the next season, the next premiere? I'm not going to talk about this in detail just because we're pressed for time, but there's also a project called Oasis, another one called Diamond, that use diffusion techniques to basically create the world as you go. So if you were to go to this website on your own time, you could steer a game where each frame in the game gets generated as you move forward to it, but there is no game engine itself. It's an engineless game, so to speak. Okay, moving on to level 3, narrative instances. I want to talk a little bit about something that I think affects us all, is how we harness this procedural power, right? How we make compelling stories, how we share them with our players. Now, we're very lucky to have narratologists in the room with us today who focus on ludology and game development, game studies. And I want us to be reminded, thanks to Hartmut's excellent lecture too, that we have this lens of thinking about games already in terms of a proto-story that lends itself very well to thinking about games in the AI era. Okay? The proto-story is an unfixed content for our interactive digital narrative. It's a charged volume of possibilities rather than a single story that comes out, like almost like a movie tells one story, a game could tell a million stories, right? And I like to think about Hartmut's approach, and please correct me if I'm wrong over drinks later, I like to think about it as the magnetic field around a compass. Right? You can't see these lines as the person who's interacting with the compass, but the needle can detect which way the magnetic fields are going. And I think about LLMs as the perfect companions for that field. Instead of branching down hard-coded dialogue trees, LLMs can sample from the proto-story's latent space, improvise dialogue, improvise quests, provide twists that are coherent because they remain tugged by those underlying vectors. Right? These could be constraints about the lore of the game, the psychology of the NPCs, or thematic beats. And if we think about the proto-story as a prompt, imagine this for a second. Here I have an image, and I want you to visualize that you're approaching this desert outpost. It's like Star Wars without the sci-fi, okay? And in this town, it's kind of like Waterworld. Everyone's desperate for this rare resource, and you're going on quests to dig a new town well. And the thing is that none of this story has been written yet. We just have this core idea. And instead of designers trying to plot every single branch and tailor every possible experience the player will have, I want us to think more in the emergent direction of how will these tales tell themselves, right? How will the stochastic storyteller provide the moment-to-moment weaving while we provide the larger scale direction? That is to say, instead of scripting the script, how do we script the space? How do we get from narrative encoding to narrative jazz, right? We want to have riffs, we want to have beats, right? But we want it to feel fresh every time as well. So this brings us to a kind of an experimental project called Covert Protocol. Now, Covert Protocol is a demo from NVIDIA and InWorld where they work together using a bunch of local computation with some cloud computation to create an experience where you could interact with an NPC who only had that proto-story to build off of with some kind of story beats to skeleton around to. And as you watch, I want you to understand some of the things that are happening. First of all, the reason the responses are so quick is because they're using like on-device, whisper and text-to-speech systems. That way, it feels quick. And I think I already said that. Second, we maintain coherence with the game world and the story by operating within the guardrails of what's supposed to happen to move the story forward. We're not just saying, "Hey, tell us about an old Western." Like there has to be a mission, and we're going towards that mission with every step. And then the third thing is that we're getting some type of face lip sync synthesis happening, which is also important, right? Because we want it to feel real, and we achieve that verisimilitude by making sure that it doesn't just come out Oblivion style with awkward movements. Okay, let's watch the video. It'll speak for itself.
Social simulation game mechanics. In this video, diving into how in-world is powering cognition, perception, and behavior for the AI agents in the game. Diego is an executive at X.Ren. He has a rich backstory powered by his personal knowledge, as well as common knowledge that he shares with other characters. When you meet Diego for the first time, he is brusque and dismissive. What's your speech about?
Not interested in discussing it with someone who isn't a VIP at the conference. Moving on.
The player's response can be captured on device and passed to NVIDIA Riva automatic speech recognition and then passed to in-world for inference. Now let's see what happens after the player has obtained the conference badge and pretends to be an attendee. You look sharp. Where'd you get that suit?
Thank you, sir. I have a personal tailor who always makes sure I'm dressed to impress.
Behind the scenes, several in-world systems and models are working together to orchestrate Diego's response. The player's voice input can be captured on device by NVIDIA Riva automatic speech recognition, and the text transcript is then passed to in-world for inference. When the player introduces themselves as Alex Miller, the name on the conference attendee badge, this triggers a mutation of Diego's motivations and demeanor, making him more collegial and friendly with the player. Intent-based mutations are also used to trigger changes to the player profile from tourist to attendee to aid an agent's cognition. We've added a customized reasoning step to evaluate the interactions and dynamically evaluate motivations. Customized reasoning allows AI agents to simulate human-like decision-making processes, engage in complex interactions, pursue their own goals, and create dynamic gameplay scenarios. Strict safety filters are enabled for topics like politics and religion, which are not topics that the character should comment on.
So I'll continue because we're pressed for time. One of the big theories behind this was already presented to us by Nicholas Sealis, right? That is the theory of the three-actor AI, that the story actually is going to be constituted in concert with the player, and that's what this example, exemplifies so well, is that there is a way to create the story in concert with interaction with the player, and that type of co-constituent narrative is essential. This is, of course, in contrast to something like The Witcher 3, where we created 36 different endings based on decisions that were made along the way. Now, I want to just quickly jump to something a little bit more inspirational, right? And summarize as we wrap up. First, there's noise. It's everywhere. It's valuable. We need to use it. We have many talks happening this weekend about how to transform it more effectively. Second, there is a reality regarding our craft, right? Over the past 4 decades, gaming changes at the frontier with technology. We'll have to decide how to use these tools judiciously and effectively for our audience. The third thing is, if Gary Gygax was listening to all of this today, it would be standing the model of D&D and original RPG construction on its head. The idea that it's not just one person who tells the whole story. It's in fact going to be in the future us telling the story to the game so that the players can share that story going forward. And that is something really novel for us. Now, I would like to end with something inspirational. It was something that inspired me. I hope it inspires you as you build your games.
It's not your job to create your vision. It's your job to have a vision. And then it's your job to hire talented individuals, to hire talented artists who understand your vision. And you articulate it to them. And then they take your vision and they create it. And by them creating it, you part back a little bit, you add a little bit to it, but your vision is still a two-dimensional vision. They will take the different elements of your vision and make it three-dimensional. And then you'll get back more than you gave them, and then you'll know even more what you're talking about and what you're singing, and then the vision will get filled in. You think you have to do everything, and you don't. You don't need to know anything about sewing to have wonderful costumes in your films. You just need to express what you want to the costume designers. You don't need to have a degree in engineering to have magnificent sets in your pieces. You need to describe what it is you want. You don't need to know how to take a bunch of different light stands and put them together to create a specific lighting effect, that's not your job. You don't need to know any of that. What you need to know is you need to have a vision and you need to know how to express it. And then you let the other people take it and do it for you. That is what a director does. I can't tell you how that sort of Damocles that hung over my head from the moment that I tried to really seriously consider being a filmmaker, how daunting it was. And because I didn't go to film school or anything, it was like, there was always this argument that I always had with myself. Is this real, or am I just being a dreamer? And the fact that I didn't know how to do those different things always put me in the debate amongst myself, dreamer or artist. That was always ammunition for the dreamer side of the debate. And in one answer like that sort of Damocles went away. Because I did have a vision, I did know what I wanted, and I could describe it. That I could do, I can describe it, I can talk about it. That is what I know I can do. And pretty much since then, that's what I did. And that is how, if you think my films have a certain look or a certain aesthetic, that is how I created it. I've worked with very talented people and described to them ad nauseum, through both my descriptions and through cinematic examples and through comic books and through all kinds of different other little multimedia things that I like to evoke. That's how I've gotten it across.
Thank you.
I don't need any questions. I'll see people later.
Okay, sounds good.
Yeah.
Well, Laila, Jhane.
Paid for lunch but have not gotten your lunch ticket. You'll actually need a physical lunch ticket, so make sure you grab that at the registration. They've got the list of names of everyone who paid for lunch, so make sure you have that ticket before you head over after Laila Jhane's presentation. And Laila Jhane's been doing incredible things. I'd love to talk about how we met, but you definitely need to check out Laila Jhane's website for some very cool AI videos already. And I'll just say that at Atlanta AI Week, it was very fun watching people in the audience already involved with AI being blown away by everything Laila was saying on her own panel. So I'll turn it over to you and let you make this rock.
Thank you so much. I should have let you know it's Laila Jhane. Jhane.
Okay.
No, it's okay. No, it's all good. I get that a lot. Hey everyone, I'm Laila, and I'm really excited to be here. There's been a lot of amazing speakers before me, and I'm very thankful that you used the film segue for me, because that's actually more of my background. I've been transitioning into being a new media artist, but traditionally I've been working in the documentary field. And I guess to give a background, I had the opportunity to go to a tech conference around 2 years ago now, where they were speaking about what was going to happen with AI and how it's going to affect various industries. And I raised my hand and said, okay, well, what should people do to prepare? And no one had the answer, obviously. And so I took it upon myself to start learning and seeing how I could use these tools and how other artists can use these tools. So I'm going to go ahead and segue into the next slide. Oh. do structure transformation, so you can see, you know, how close or how far away you want it to be from your actual input. And it also gives you different templates that you can use to create your output. You can also create a custom one. I did that with a Barbie version of it, and I'll show you in a I'll show that in a second. But yeah, and this is another one. It's very silly. The arm's still really wonky, and yeah. But the reason I show you this, and you do not have to do it the way I'm doing it, this is more so just an example. Think about how you can take your creative expression and turn it into something different and just elevate it or change it. Do whatever you desire. I think that these tools really provide a great opportunity for people to realize the intersection of art, technology, creativity, all those things, in that the only limitation that you have is your mind. I understand the ethical concerns, and I understand the certain grievances people have. But as a filmmaker, artist myself, what I've come to really think about and consider is how can I use these to enhance my craft, and also how can I use these tools to start creating culturally relevant things. There's a professor, she's somewhere in Boston, but her name is Dr. Natrice Gaskins. She has a textbook called Techno-Vernacular Creativity. It's about utilizing technology to make culturally relevant spaces or to make culturally relevant things. And I don't know if everybody's familiar with what a maker space is, but it's just when you can build. She was using the reference of music and how, and I can relate to this as growing up being a musician myself and playing instruments, how you can just create, the ability to just create from your hands, from your thoughts freely as a form of expression. And I've come to feel the same way about generative AI and how it can sort of give that ability to enhance my ability to create and to create culturally relevant things for myself or others, that opportunity to create culturally relevant things. So whether you live in Kennesaw or you live in the West End of Atlanta, how can you utilize these tools to tell that story of where you're from? And I think that is a really great opportunity that these tools provide. Wanted to kind of, if we have time, I think, yeah, go through creating something. And so I'll leave that to the crowd. I'd like that to be more of an interactive thing. If somebody has something they, oh, yeah, okay. Okay. Okay, I'll put the mic down. Ooh, I'm back. Okay. Okay, so we'll let it start to create that. And while I was creating that, I'll talk about some of the limitations that I've seen with these tools. It's definitely not as good as being someone that understands code and someone that can clean a lot of this up and knows what they're looking at. Because to me, I don't code. I don't know anything about code. But I don't think that should be a hindrance, kind of referencing what Quentin Tarantino said, that shouldn't be a hindrance on creativity and what I can create and what other people can't create. But I do think that a lot of times I think about generative AI as it meets you at your comprehension level, but it also gives you the opportunity to enhance your comprehension level. So for instance, if I read on the 5th grade level of a 5th grader, it'll meet me at the level of a 5th grader. If I read at the level of a college-educated student, it'll meet me at the level of a college-educated student. But that doesn't mean that it can't help you progress either. So even though I may currently be reading at the comprehension 5th grade level, it gives me the opportunity to enhance my comprehension to that college grade level
by meeting me where I'm at and allowing me to grow. So I think that that's a great, use that as an example of, although I may not know code, this gives me a great segue into starting to want to understand it and know the background and things of that nature. Whew. Does anybody have any questions while this? Oh, okay. Oh, that's kind of cute. An old silent pond, a frog jumps into the pond, splash, silence again. That's actually really cool. And did it on the first try. It treated me right this time. Yeah, so typically what I would do is let's go to OBS Studio. I would go here. Is anybody familiar with OBS Studio? Oh, shout out. Cool. Let's see. And let me see. Properties. Okay, let's go. Oh, I'm at the wrong one. No, I'm at the right one. Why? Discard this. Okay. Window capture. Yep, window capture. And we're going to go to. Okay. Why are you doing this? Oh, I know I'm doing wrong. Okay. Dang, I did not mean to close that window, but it's okay. Hello? Show me where you're at. Bear with me. Discard. Let's just do a new one. I can't figure it out. Screen capture. Okay. Window. Why is it not showing me? Here it is. Okay. So what I would do is I would do this. Check time. Okay, we're good. Do this. No. Okay. Oh, I missed the moon. No, we gotta have the moon in there. It's okay. I'll just crop it in. There. All right, cool. And so I'll just screen record that for about, I'll wait for it to get to about 10 seconds or 15 seconds. Stop recording. We're going to go to Runway ML and we're going to put in a new input. Cool. Oh, cool. Can I do this? I don't want the moon to be gone, but that's going to be okay. Right there. All right. And I'm just going to take this prompt. Where am I at? Here I am. Okay, let that load. Cool. So, for the sake of time, I'm going to use a template. Does anybody? Let's see. So these are my custom ones. Let's see. What should I do it in this? What template should I use? I will use origami. That's great. Okay. So you see how it gives you the template, and then you can implement your prompt there, and then it'll create it. So yeah, let's do that. Paper art, intricate origami, a Japanese haiku animation in the style of delicate folds, Japanese craftsmanship, geometric precision. So let's generate. And I want you guys to know I don't have unlimited Runway ML. I wish. I signed up for the Gen 48 film competition that they do, and so I guess I got unlimited generations, but yeah, I don't have that myself. And I would say, I don't really time it, but I feel like it takes about 1 minute to 2 minutes for your generation to come to existence. And while it's doing that, because it takes a little while, I'm going to go to my site, and I'm going to show you something else. So these are all the projects I've made utilizing generative AI. It's really cool. But this one I want to talk about too. So with this video to video I did, I was able to take footage from my camera and run it through the tool and utilize the templates that they provided. And also I created a Barbie one, which was cool. And I really was doing it to test and see the precision as to how it would interact with some of the, even when I was filming, when I got too close, it messed up the depth of field, so it was blurry, and then I was able to back out. And I was really just testing out to see what it would do. And I found it to be so interesting and intriguing to think that you can take a video and turn it into something completely different. If anybody's familiar with VFX and just how intricate that is, I found that to be a really cool and interesting thing. Oh, there was an issue. They better. I need more unlimited. Yeah, so I'm gonna let that do that. We'll use another, actually also we'll use another template. So let's see, Japanese animation. Okay. Maybe I need to take out the word animation and just use haiku. And can I see the, oh, and this is another really cool thing. So there's this thing called first frame, where essentially I could take this first frame, download it, run it through a tool like Magnific or Midjourney, change what it is visually, and then restyle it. So the video will turn into that. So if you want it to be more specific to what you visually have in mind, you could do that as well. I really hope it does it. Okay. So, yeah. Let that do that. What else? I think I've touched on this. Oh, we already did that. Can I go to the next slide? Okay, we're doing the video. Oh, and this is a quote, but I'll end that. Oh, Lord. I'll end that in a second, though. It's fine, I don't care. You guys can see it. See how the meat's made. Okay, this is interesting. This is what we got from the, video to video. I don't know what's happening. Oh, I know why. Let me exit out. There we go. I should stop doing that now. It's not, it's just being glitchy. It's okay. As you can see, it really didn't take our words, and also it was really glitchy. It didn't take our words and put it how it was before. And again, that's another limitation with video to video. It doesn't really understand words. It kind of seems like gibberish, because it is gibberish. But let's see what it did. Okay. Yeah, well, that's what it did. It took our original input, or what we got from Claude, and it turned it into this. And I'm sure if I would have just went lower, it would have been closer to my input, so I'll see. But also, yeah, I'll open up the floor to questions as it does that. I'm sorry? Exactly. It didn't give us the frog. So I'm trying to regenerate it. But yeah, I'm here to show you guys limitations, not a completely different haiku. Yeah. I'm surprised you're able to read that. It seems like gibberish to me. On this right side. Oh, we're talking about right here. Question? Yes.
Okay. So we're continuing on that conversation for the group, right? It strikes me that this workflow is like playing Catan with a young child.
Yeah.
Where you say, I need, bricks and wood,
Yeah. Yeah.
It's kind of like that, where you basically like, here I've got an initial impulse, and then here's one generator, pass to another generator, pass to another generator. Now I've got a chain of generators, each kind of injecting more, I don't know, like almost like randomness into it. Right?
Yeah.
And there's so much potential here with sufficient iteration.
Yes.
Right? Who knows what could pop out of this that would then be a valuable nugget to pass to the next in the chain.
Yeah.
It's really, and by the way, you have incredible demo luck. I just wanted to comment. This is the second time I've seen you present, and your luck during the live demo, incredible. I wish I had that.
Thank you so much. Thank you. That's actually hilarious. There's an issue again, but okay. It's gonna keep acting up. So in the meantime, I wanted to show you that and show you the video. But also, you made a really great point, and I want to show you something. So this right here is a project I made utilizing fully AI, and this was not video to video, but I want you to think about how. I just want you to watch it. Watch the first 30 seconds.
When the alarm goes off at 4:30 a.m., doesn't matter if it's Christmas or my birthday, the farm needs tending. Last year's drought hit us hard, lost about half our corn crop. You'd think after 40 years I'd be used to the uncertainty, but it still keeps me up at night. Sometimes I wonder if I'm the last generation to work this land.
Okay. The reason I show you that is you talked about iterations. I still had to clean a lot of that up, utilizing Adobe software and After Effects, Photoshop, all of that. And so while I'm showing you how you can utilize these tools as a workflow and as pre-visualization, all those things, I also want you to think about how it still takes a lot of effort from you, and it still takes a lot of understanding of how to tell a story. It's not as simple as just creating. As you'll see, a lot of people are doing that right now, but the people that'll be the standouts will be those that understand story and also are highly creative. And last thing, because I have 3 more minutes, I want to leave you with this quote from Peter Gallison. He's actually a professor at Harvard. The image is an integral part of this new matrix of power, and I think that we don't really understand where it is going or what it will become. The searchable, cheap image, the archives of our lives. These will, I am sure, transform our way of life and our concepts of power. He was using this quote to speak about images, photography, apertures of photography magazine, and just thinking about it in terms of how generative AI is challenging our beliefs on what visuals are and what is authentic and what is not authentic. He referenced in this book how encyclopedias actually used to be sketched. So they used to sketch, let's say an orange. This is what an orange looks like. And then once the first camera was created, they started taking pictures of said orange. But those images were still manipulated. And so what I think he was really trying to say is that, not just with this power thing, but talking about how reality is, our concept of reality is kind of manipulated. And so in terms of, there's 2 fronts, but in terms of AI, generative AI, I think that it's just a new form of reality. And I don't know what's going to happen with it. There's a lot of great professors that have a prominent background in that. But I do think that this is an opportunity for us to really consider what we would like that reality to be. And so for every single person to be a part of that is highly important. I mean, most people in this room, I would assume, have a background in this, but your everyday person that's utilizing these tools, your everyday person that is trying to become better at whatever they're doing, I think that that is going to be the most interesting thing that will show us what will come from these tools. So, yeah, thank you.